Which equation is represented by the graph below? I've taken this graph not directly from the book, but I've recreated the graph in the book using graphing tool, and I've marked some of the key points on there. We have a graph from 0 to 2 pi, and the asymptotes are at pi over 2 and 3 pi over 2, and I've also shown pi in the middle. And they want to know, is this the graph of cotangent of x, cosecant of x, secant of x, or tangent of x? So let's take these one at a time. What is cotangent of x? Cotangent of x is the inverse of the tangent of x, right? And the tangent is opposite over adjacent, so the cotangent must be adjacent over opposite, which, if we're looking at a triangle on the unit circle, that's like saying x over y, right? So just draw, if you don't remember, draw the unit circle and draw a random triangle on it, and the opposite is y and the adjacent is x and the hypotenuse is h. And also, if it's the unit circle, the hypotenuse is always 1, so you can just think of that as 1 if you'd like. The next one is cosecant of x, which is 1 over the sine, if you recall, and the sine is opposite over hypotenuse, so we'll just jot that down, opposite over hypotenuse, which in this case is y over 1. Right? That's the sine. Oh, actually, the sine is opposite over hypotenuse, so the cosecant is hypotenuse over opposite, right? So this is hypotenuse over opposite, which is really 1 over y. Okay? And the secant is 1 over cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, which is 1 over x. And lastly, the tangent. I didn't put an x in here, so put that there. Tangent of x is opposite over adjacent, which is y over x. Okay, so how do we begin to kind of sift through these different choices and figure out which ones could be the graph? One way might be to actually just put each of these 4 choices into your calculator and see which one looks like this. If you're going to do it that way, make sure you graph it from 0 to 2 pi on your calculator. Otherwise, if you get some other window of x values, then the graph might look different. You might think it's wrong, and it may be right. But if you want to try to figure it out, then once you have these, what you need to think about is where those asymptotes are located. So on the unit circle, you have, oof, that's terrible. On the unit circle, we have 0, pi over 2, pi, and 3 pi over 2. And you know you have these asymptotes at pi over 2 and 3 pi over 2. So that's here and here. And what does that really mean? Well, an asymptote means it's undefined, which means you have something over 0. So if you have something over 0, what equals 0 at both of these 2 points? X or y? Well, x does, right? Because they're both on the y-axis, where x equals 0. So at both of those points, x equals 0. So that means the answer could be secant or tangent. These are the ones that we're keeping in, but not these two. These two don't make sense because they have y in the denominator, and y doesn't equal 0 at those points. I hope that makes sense. And then now we have to decide between secant and tangent. So the best way to do that is to think about where the secant and tangent are positive and negative. So let's take secant for example. Secant is 1 over cosine, so wherever the cosine is positive or negative, the secant will be positive or negative in the same place. So we notice on the graph, between pi over 2 and 3 pi over 2, it's always negative. So on the unit circle, between pi over 2 and 3 pi over 2, what's always negative? Well, the cosine is. Right? The cosine is always negative in the second and third quadrants because it correlates with the x-coordinate, and the x-coordinate is always negative over here, so the cosine is always negative over here in 2 and 3. And so the secant is always negative in 2 and 3. So it's looking better and better for the secant. Now what happens in the other quadrants? Between 0 and pi over 2, between 0 and pi over 2, first quadrant, the cosine is positive and the secant is positive. And what do you notice about the values? They're positive. Same over here, between 3 pi over 2 and 2 pi, that's the fourth quadrant now, all the values are positive. So that's true for the cosine, that's also true for the secant. And that's the best choice. The best choice is secant. And if you're still wondering, well, why can't it be tangent? Let's think for a minute about what's happening with the tangent. The tangent is positive where? Tangent is positive in the first quadrant and the third quadrant, because here x and y are both positive and here x and y are both negative. And so when we look between 0 and 2 pi, we say it's positive. Well, it's positive on the graph too, so that's good. But then we look between pi and 3 pi over 2, which is here, between pi and 3 pi over 2, and we would expect to see a positive value, and we don't. We see negative values. So that's why it can't be tangent. And again, I do encourage you to use a graphing calculator on this one, but this is how you would think through it without using the graphing calculator. And you also might remember, just in case you've done some graphing of tangent functions during the year, the tangent is typically graphed from negative pi over 2 to pi over 2 and has this general shape. And you can show that on your calculator as well.